Could the first alien life we discover be swimming right now? In the dark shadow of Jupiter meet Europa. On the surface, it is a radioactive graveyard frozen harder than granite. It looks dead, but beneath that scarred ice lies a staggering secret, a hidden warm ocean holding twice as much water as all of Earth combined. It is the perfect cradle for life, but we didn't find this ocean with our eyes. We found it because the moon sent us a message. It started with a single impossible electromagnetic signal. That signal arrived in 1997. NASA's Galileo spacecraft executed a daring flyby skimming just above Europa's surface. Its mission was to scan rocks and ice. But suddenly, its magnetometer screamed. The instrument recorded a violent distortion in Jupiter's magnetic field, a signature that physics dictates should not exist on a dead world. Rocks are electrically silent. Ice is an insulator. This anomaly was a planetary confession. It proved that something inside the moon was conducting electricity on a massive scale, and in the freezing vacuum of space, only one substance could do that: salt water. To understand why a magnetic blip on a sensor translated into the discovery of an alien ocean, we must look at the invisible architecture connecting Europa to its host planet. Jupiter is not merely a gas giant, it is a colossal magnetic powerhouse. Its magnetic field is tilted by about 10 degrees relative to its rotation axis, meaning that as the planet spins, its magnetic north and south poles whip around like the lights of a lighthouse. Europa, orbiting within this chaotic environment, is subjected to a magnetic field that constantly changes direction and intensity. This dynamic environment created the perfect setup for a cosmic experiment based on the principles of electromagnetic induction. Think of Jupiter as a massive airport security scanner and Europa as a passenger walking through the gate. If a passenger is made entirely of plastic or wood insulating materials, the scanner remains silent. But if they are carrying metal, the scanner screams. When Galileo passed by, the scanner screamed. The physics behind this is governed by Lenz's law. As Jupiter's changing magnetic lines of force sweep across the moon, they induce electrical currents inside any conductive material beneath the surface. These internal currents in turn generate their own magnetic field, a counterfield that pushes back against Jupiter's. The distortion Galileo detected was not a random anomaly. It was the magnetic signature of these electrical currents flowing through the moon's interior. The moon was acting like a giant spherical generator, converting Jupiter's magnetic energy into an electrical response. The question then became, what substance inside Europa is capable of conducting electricity on such a planetary scale? The detection of this induced field triggered a process of scientific elimination. The detectives at NASA had to identify the conductor hiding beneath the crust. A metallic iron core, typical of rocky planets like Earth, could conduct electricity, but Europa's core lies thousands of kilometers deep too far away to account for the specific geometry and strength of the signal Galileo picked up. The response was coming from much closer to the surface. Could it be the ice itself? Pure water ice is an electrical insulator. It blocks current rather than conducting it. If Europa were a solid ice block frozen down to the bedrock, it would be electrically invisible to Jupiter's scan. Molten rock or magma was another candidate, but for a moon, this small to maintain a global layer of magma just beneath its crust would defy thermal models. It would have cooled and solidified eons ago. This left only one viable suspect, a layer of liquid water. But not just any water. Pure fresh water is a poor conductor. To generate the strong electrical currents required to create the observed magnetic counterfield, the fluid had to be an electrolyte. It had to be salty. Dissolved salts break down into ions, allowing electricity to flow freely. The data pointed to a single inescapable verdict. Europa is wrapped in a continuous global shell of salt water, likely similar in conductivity to Earth's oceans. This layer isn't a series of isolated underground lakes. It is a unified, encompassing sea that disconnects the icy crust from the rocky mantle below. The magnetic data confirms the existence of a global ocean. However, this creates a thermodynamic contradiction. At this distance from the sun's surface, temperatures plunge to minus 170 degrees Celsius. By all laws of physics, this water should be frozen solid. For liquid water to persist for billions of years, Europa requires a continuous internal source of heat. If Europa relied solely on the sun for warmth, it would be a frozen block of ice, as hard as granite. At nearly 800 million kilometers from our star, the surface temperature plunges to minus 170 degrees Celsius. Yet the magnetic data proves the water is liquid. The energy keeping this ocean alive does not come from above, but from a relentless engine of gravity operating below. The key to this internal fire lies in Europa's relationship with its siblings. It is locked in a precise rhythmic dance known as the Laplace resonance with neighboring moons Io and Ganymede. For every orbit Ganymede completes, Europa completes 2, and the volcanic moon Io completes 4. This gravitational choreography prevents Europa from settling into a perfect circle around Jupiter. Instead, it is forced into an eccentric, slightly elliptical path. This deviation is crucial. As Europa swings closer to Jupiter, the planet's immense gravity pulls harder, stretching the moon into a slight oval shape. When it swings further away, the gravity weakens, and the moon snaps back into a sphere. This cycle happens every 3.5 days. It is a process of gravitational kneading, similar to repeatedly bending a metal paperclip back and forth. Just as the metal heats up from the stress, Europa's rocky interior and ice shell heat up from the internal friction of this constant flexing. This process, known as tidal heating, dissipates terawatts of energy into the moon's interior, enough thermal power to keep the subsurface layer permanently melted, sustaining a liquid ocean for billions of years without the need for sunlight. The reservoir created by this gravitational engine is not merely a series of pockets or lakes, it is a global hydrosphere of mind-bending scale. Current models derived from gravitational measurements and the magnitude of the induced magnetic field suggest that this ocean is approximately 100 kilometers deep. To put that into perspective, the deepest point of Earth's ocean, the Mariana Trench, is only 11 kilometers down. If you were to peel away Europa's ice shell, you would find a layer of water so vast that despite Europa being only 1/4 the size of Earth, it holds nearly twice as much liquid water as all of our planet's oceans combined. This is a planetary battery of immense capacity. The water here is under colossal pressure, increasing with depth to levels that dwarf the crushing physics of Earth's seafloor. Yet unlike the stagnant waters of a trapped aquifer, Europa's ocean is likely dynamic. The heat rising from the rocky mantle below and the cooling from the ice shell above would create convection currents, circulating nutrients and energy throughout the globe. It is a dark, silent, and high-pressure world, but it is stable. While Earth has undergone snowball events and extreme climatic shifts, the insulation of the ice shell and the constancy of Jupiter's tides may have kept Europa's ocean in a stable liquid state for 4 billion years, providing a calm, uninterrupted cradle for potential evolution while the surface above remains exposed to the harsh vacuum of space. If tidal forces are constantly flexing the moon's interior to generate heat, this mechanical stress must also affect the outer crust. Observational evidence supports this model. Europa's surface is not a solid, static shell. It is a fractured landscape physically broken by the churning motion of the ocean beneath. While the moon lacks the heavy cratering seen on Callisto or Ganymede, indicating that its surface is young and constantly refreshing, it is scarred by a different kind of wound. The most striking features are the chaos terrains. Vast regions like Connemara Chaos, where the icy crust has been completely shattered. From orbit, these areas resemble a giant jigsaw puzzle that has been violently shaken and frozen mid-collapse. Massive blocks of ice, some the size of cities, have been tilted, rotated, and flipped on their sides before being locked back into place. This is not the result of external impacts, but of internal sabotage. The leading theory, the ice raft model, suggests that heat from the underlying ocean creates plumes of warm water that rise and melt the bottom of the ice shell. As the foundation weakens, the brittle surface above fractures and collapses into the slushy matrix below. These icebergs drift and rotate, floating on a temporary sea before the region refreezes. Crucially, these scars are not white. The fractures and chaos regions are stained a deep reddish brown. Spectroscopic analysis suggests these stains are not merely ice, but deposits of salts, likely magnesium sulfate or sulfuric acid, that have surged up from the ocean and been cooked by Jupiter's radiation. In the eyes of a planetary geologist, these red stains are chemical couriers. They are physical proof that the barrier between the vacuum above and the ocean below is permeable. The depths are breaching the surface, bringing their chemistry with them. And in 2023, this investigation received a crucial new witness. The James Webb Space Telescope, pushing its infrared vision to the limit, detected concentrated carbon dioxide within these very chaos terrains. This is not a coincidence. It is the smoking gun, proving that the ocean below is not just salty water. It is holding the fundamental building block of life, carbon. If the chaos terrains are the fossilized remains of past upheavals, the water plumes are evidence that Europa is erupting in real time. The planet is effectively breathing water into space. The first hint came retrospectively from Galileo data, where a dip in plasma density suggested the probe had flown through a cloud of neutral gas. But visual confirmation remained elusive until the Hubble Space Telescope pushed its optics to the limit. In 2012 and again in subsequent years, Hubble detected faint ultraviolet signatures silhouetted against the light of Jupiter, towering columns of water vapor, shooting up to 200 kilometers above Europa's south pole. These are cryovolcanic geysers powered by the immense tidal pressure building up inside the moon. When the crust flexes and cracks near the point of maximum stress, the pressurized water from the subsurface pockets, or perhaps directly from the ocean, blasts upward into the vacuum. The volume is staggering. It is estimated that every few minutes Europa vents a mass of water, equivalent to an Olympic-sized swimming pool. For the search for life, this is a game-changing phenomenon. It means that to study the ocean, we may not need to drill through 20 kilometers of ice immediately. We can simply fly through the plumes. Europa is effectively offering up free samples of its hidden ocean, spraying its chemical secrets into the void, waiting for a spacecraft to catch them. We have confirmed liquid water and a heat source. These are two of the three requirements for life. The third is chemical energy. For biology to function, it needs a continuous supply of chemical ingredients, specifically a balance between oxidants and reductants. The challenge is that Europa's ocean is capped by kilometers of ice, theoretically isolating it from chemical sources on the surface. A sealed ocean, no matter how vast or warm, faces a suffocating deadline. Without a way to cycle chemicals, specifically oxidants, into the water, any biological activity would eventually consume the available chemical energy and die out. Life needs a battery. It needs a difference in electrical potential between what it eats and what it breathes. In the deep oceans of Earth, this balance is maintained by the mixing of surface waters, rich in oxygen from the atmosphere. But Europa has no atmosphere to speak of, and its ocean is capped by a lid of ice tougher than concrete. However, the cosmic detective investigation reveals that Europa has found a way to cheat this suffocation. The solution comes from the most unlikely of sources, the deadly radiation of Jupiter. The surface of Europa is a chemical factory running on overdrive. As the moon orbits through Jupiter's radiation belts, its equatorial regions are bombarded by high-energy particles. This relentless assault triggers a process called radiolysis, the splitting of molecules by radiation. When these charged particles slam into the water ice on the surface, they shatter the H2O bonds, separating hydrogen from oxygen. The lighter hydrogen often escapes into space, but the heavier oxygen atoms, along with potent oxidants like hydrogen peroxide and carbon dioxide, remain trapped in the ice lattice. Models estimate that Europa's surface generates up to 12 kilograms of pure oxygen every single second. If this oxygen stayed on the surface, it would be scientifically interesting, but biologically useless. The breakthrough lies in the moon's active geology. The same tectonic forces that shatter the chaos terrains act as a planetary conveyor belt. Through a process of subduction similar to the tectonic plates on Earth diving beneath one another, slabs of this oxygen-rich surface ice are forced downwards. Over millions of years, this heavy, cold, oxidized ice sinks through the warmer shell until it melts into the ocean below. This mechanism effectively turns the entire ice shell into a planetary lung. Europa is inhaling oxidants on the surface and exhaling them into the deep. If this cycle has been active for billions of years, the concentration of oxygen in Europa's ocean could rival that of Earth's deep seas. This changes the biological profile completely. We are no longer talking about a stagnant pond capable of supporting only sluggish anaerobic bacteria. We are looking at a highly oxygenated environment that contains the chemical fuel necessary to support high metabolism life forms, potentially even complex multicellular organisms. While the surface provides the breath in the form of oxidants, the seafloor likely provides the food in the form of reductants. Deep below the ice, where the pressure crushes with the weight of 100 kilometers of water, lies the boundary between the ocean and the rocky mantle. This is where the magic of a second genesis likely begins. On Earth, we once believed that all life ultimately depended on the sun. That dogma was shattered in the 1970s when explorers discovered hydrothermal vents, black smokers, teeming with life in the abyssal darkness. These ecosystems run not on photosynthesis, but on chemosynthesis. Microbes harvest energy by breaking down chemical compounds like hydrogen sulfide and methane gushing from the planet's crust. The evidence suggests Europa possesses this same engine. The tidal flexing that heats the ice shell also needs the rocky core. This internal friction likely drives volcanic activity on the seafloor, creating vast fields of hydrothermal vents. As seawater seeps into cracks in the hot rock, it undergoes a reaction called serpentinization, becoming superheated and mineral-rich before blasting back out into the ocean. This creates a chemical oasis in the cold dark. We have a direct analog for this on Earth Lake Vostok in Antarctica. Buried under 4 kilometers of ice and isolated from the atmosphere for millions of years, Vostok was thought to be sterile. Yet when scientists drilled into it, they found a thriving community of microbes fueled by minerals from the bedrock. Life endured in the dark, crushed by pressure, starving for sunlight. If life can survive in Lake Vostok, the odds favor it surviving on Europa. But the presence of oxygen from the surface allows us to dream bigger. On Earth, chemosynthetic bacteria form the base of a food chain that supports giant tube worms, ghost crabs, and spectral fish. With a steady supply of oxygen from above and chemical nutrients from below, Europa's ocean could theoretically support a complex ecosystem. We are not just hunting for microscopic slime. In the oxygen-rich currents of this alien sea, it is biologically plausible that larger creatures swim in the eternal night. Predators and scavengers evolved to navigate a world of sound and chemical trails rather than sight. The cities in the dark may be populated not just by bacteria, but by the first extraterrestrial animals we will ever encounter. Hypothetically, the conditions for a biosphere are present. To verify this, we must send spacecraft to collect direct data. However, exploration faces a significant physical barrier. While the subsurface ocean may be habitable, the environment surrounding Europa is destructive. The Moon orbits deep within Jupiter's magnetosphere, a region of intense particle radiation. Jupiter acts as a terrifyingly efficient natural particle accelerator. Its magnetic field traps charged particles, ions of sulfur and oxygen spewed from Io's volcanoes, and whips them up to speeds approaching the speed of light. Europa orbits right in the firing line of this subatomic artillery. The result is a relentless, invisible hailstorm of high-energy electrons and ions that bombard the Moon's surface with ferocity. For a human standing on the ice without heavy shielding, the environment is instantly lethal. The radiation dose on the surface is estimated at 5,400 millisieverts, or 540 rem, per day. To put that in perspective, a dose of 4,000 to 5,000 millisieverts is enough to kill a human being. On Europa, you would receive a lethal dose in under 24 hours. But the challenge isn't just biological, it is technological. This invisible hail shreds DNA, but it also destroys silicon. High-energy particles penetrate the casings of spacecraft flipping bits and computer processors, corrupting memory and frying sensitive sensors. It is an electronic kill zone. To send a probe here is not merely an act of exploration, it is an act of engineering warfare. To breach this fortress, NASA has built the Europa Clipper, the largest spacecraft ever developed for a planetary mission. It is not designed to simply endure the environment. It is designed to outmaneuver it. The mission planners realized that orbiting Europa directly would be a suicide mission. The probe would be cooked by radiation within months. Instead, they devised a brilliant tactical solution, the hit-and-run trajectory. Clipper will not orbit Europa. It will orbit Jupiter in a wide looping path that keeps it safely outside the worst radiation zones for most of its time. Every few weeks, it will dive in screaming past Europa at high speed to snatch gigabytes of data and then immediately retreat into the deep cold of space to transmit its findings and let its systems recover. Over the course of dozens of flybys, it will map the moon in slices, building a comprehensive picture without staying in the line of fire. At the heart of this machine lies the vault. This is the armored chest of the mission, a container with walls of titanium aluminum alloy, nearly a centimeter thick. Inside this fortress sit the spacecraft's electronic brains, shielded from the subatomic bombardment outside. It is the celestial equivalent of a tank. Bristling from this armor is an arsenal of forensic instruments designed to peer through the ice. The star of the show is REASON, an acronym for radar, for Europa Assessment and Sounding Ocean to Near Surface. This ice-penetrating radar will blast radio waves into the crust, listening for the echoes that bounce off hidden liquid pockets or the ocean surface itself. It allows us to see into the dark, measuring the thickness of the ice shell, to determine where it is thinnest and where a future lander might have the best chance of reaching the water. Combined with the EIS cameras that can spot surface features as small as a car, and the MISE spectrometer acting as a chemical nose to sniff the plumes for organic molecules, Clipper is the ultimate codebreaker. It is a robotic ambassador built to survive the gauntlet and deliver the final proof of the ocean hiding below. The Europa Clipper is not the end of the story. It is merely the opening chapter. It is the scout sent ahead to map the territory before the true invasion begins. Once we have the map, the next step is inevitable. We must touch the ice. NASA and other agencies are already conceptualizing the next generation of explorers. The Europa lander would follow Clipper, descending through the thin atmosphere to touch down on the fractured chaos terrain. Its mission would be to dig just inches into the surface, hunting for biosignatures preserved in the freeze-dried ice. But the ultimate dream, the mission that keeps planetary scientists awake at night, is the cryobot. Imagine a nuclear-powered needle, a thermal drill designed to melt its way through 20 kilometers of ice. It would descend slowly, unreeling a communication tether behind it, like a diver's lifeline. After months of burning through the crust, it would break through the ceiling of the abyss. From its belly, it would release a swarm of autonomous micro-submersibles. These tiny robots, operating on artificial intelligence without real-time guidance from Earth, would swim into the dark, tasting the water, mapping the vents, and finally turning their lights toward the unknown to see if anything swims back. Why go to such lengths? Why spend billions to hunt for microbes on a frozen moon? The answer lies in the profound concept of a second genesis. If we find life on Mars, it is possible that it shares a common ancestor with us, hitching a ride on meteorites exchanged between the planets billions of years ago. But Europa is different. It is too far, too isolated. If life exists in that enclosed ocean, it almost certainly arose independently of Earth. Discovering a second genesis would be the single most transformative moment in human intellectual history. It would prove that the emergence of life is not a miraculous accident restricted to a pale blue dot, but a universal imperative, a natural consequence of physics and chemistry that plays out wherever the conditions are right. It would mean the universe is teeming with life. We look at Europa not just to find a germ, but to find a mirror. In the darkness of that alien ocean, we are searching for the answer to our oldest, most haunting question. Are we alone? The evidence, the magnetic whisper, the warm pulse of the tides, the breath of oxygen suggests that the answer is waiting for us beneath the ice. The ocean is there. We just have to be brave enough to dive in.